This will be the review for the quiz on logarithms. Also covered will be exponential growth and decay. You'll be given those formulas. There is a non-calculator and a calculator portion on the quiz. There are 16 questions total. 9 on the non-calculator portion. So this whole first page is the non-calculator portion. There will be, you won't need any formulas. And warning, the graph is on the non-calculator part. So some important information that you're going to want to remember is this: log, the subscript is your base. This spot is where the answer is, and it equals the power. So this says evaluate each, and so the part, of course, that's not there is that equals x. So you know that where they're asking you 2 to the what power is equal to 32. So do whatever you have to do. Again, remember, you won't have the calculator. The numbers will be small, much like these, because you know that, hopefully you know that 2 to the third is 8, and then from there you can work up. 2 to the fourth is 16. So 2 to the fifth is 32, so that means x equals 5. So for problem number 2, 4 to the what power is equal to 1 over 16. Well, we can make that 16 1 over 4 squared. To lift this up out of the denominator, you make your exponent negative. So 4 to the x is equal to 4 to the negative 2. So you can see x equals negative 2. And finally, in problem number 3, 3 to the what power is equal to 1. Well, everything to the 0 power is equal to 1. You are supposed to just know that, so that's how that works. There are 2 problems like these 3. Problem number 4, there was one like this. So write this in logarithmic form. So that means take it back and put it back with the word log. Your base is your subscript, so that's a 5. The answer goes next, the fraction, and it equals the power. Now, for those of you that have been sort of calculator dependent on your graph, this is going to really test your ability to perhaps maybe use the inverse. Oh, scary. Or just your brain. I would strongly suggest taking it out of the logarithm form and graphing it that way. You have a better chance of being able to fill in the powers that way. There are 3 questions like problem number 5. So here we have 1, 2, 3. We have 5 here. There's 3 of them, 3 of these 5. One, of course, being the graph. So I'm going to take this out. I'm going to swoop this out. So we have y to the x is equal to 4. Oops, sorry, what am I doing? I got that backwards. Don't do it that way. Oh, what's that? That's not good. Okay, so that one erase. So let's start over. Do 4 to the y is equal to x, because it's written a little bit backwards on the way we're used to doing it. So normally, you make up numbers for the x. This might be easier to make up numbers for y. I suggest you try negatives, 0. You might want to try a fraction if that's not too much. So if we put in negative 1 for y, then you get 4 to the negative first. Well, that's 1/4. If you put 0 in for y, 4 to the 0, that's a 1. And if you put 1 in for y, you get a 4. But of course, when you graph it, please make sure that you graph the x then the y. So we're going to go over 1/4 and down negative 1, 1, 0, and 4, 1. You already know what the parent function looks like, so you know that the curve goes up and to the right. You also know that there is an asymptote right there. And so it's just a matter of getting kind of the details for the graph. The domain, in interval form, well, it's not allowed to be 0, right? There's no x's that are 0. If x equals 0, we can't have that happen. So then it goes to infinity. The range, of course, you can tell bottom up, negative infinity to infinity. The asymptote, you can call this the line x equals 0 or you can call it the y-axis. That's why the domain does not have 0 in it. And as x increases, what's y doing? Y is approaching infinity, or you can use the words like they did and said y increases. Up to you. There'll be 1 expand and 1 condense and 1 solve, all without the calculator. So there's one of these kind, one like this, and one like this. So when you expand, I'm going to go through this step by step. You're multiplying. So that turns into addition. This is the natural log of x squared plus the natural log of y to the third. Now you have to put the power just in front of each piece. 2 natural log of x plus 3 natural log of y. Some of you go too fast and you miss it. You don't have the base correct and you don't put the power in the right spot. So just slow down a little bit and go through it carefully. So again, let's go through this one more time. So we're multiplying. I see 3 things, so I should have the log written 3 times. Log of A plus log of B, and then we're dividing, minus the log of D. There's no powers. There's nothing else to do. That one's finished. You can expect the same level of difficulty on the quiz. Now to put this back together, this is a power. This is a power. So now I have log of A to the third minus log of B to the fifth. You want to write it as a single log. That is to write the word log once. So the word log only gets written once. Division, so first number on top of second number. But you write the word log one time. So for this one, the natural log of z doesn't have a power. So plus the natural log of x to the 1/3 and plus the natural log of y to the 1/3. These have the same power. Remember, it's power over root for the 1/3. It's the cube root, basically what that's saying. And you can put that together. So the natural log gets written once. The z is plain. Then we have the cube root of x and y being multiplied together. Now, if you have to go slower than that and you do the cube root of x and the cube root of y, you still need to put those things together and do the cube root of xy. So even if you go slower. Now to solve this, go through this, be careful with this. Don't hurry up and cross these off. These all do have log base 3, log base 3, log base 3, but don't forget about the rules. The rules are if you're adding, it's a multiplication problem. So long before that, this is really log base 3 of 3x equals the log base 3 of 45. Now it's probably smarter to remove those. And you're left with 3x equals 45 and x equals 15. Do a quick check to make sure that you're not going to take the square root of anything negative, and we won't, and that works. Now you cannot get rid of the log in number 11. Put it back together. That's going there. So this is log base 2 of all of this. The 3, the x, everything is to the third power equals 9. So this is, I'm just looking because I was thinking, don't really expect you to do 2 to the 9th without the calculator. So I'm kind of surprised it's there. So wait a minute here, let me start over. So for this one, sorry, I'm not paying attention. Divide both sides by 3. We get log base 2 of 3x equals 3. Now you can swoop it out. 2 to the third equals 3x. So 8 equals 3x and divide by the 3. So we get 8/3. Sorry about that. I got trick-or-treaters at my door and they're distracting. All right, now for the calculator portion. This is where it starts. You will be given all these formulas. Right at the top of the page, not a separate formula sheet. All right there, same words, same formulas. There won't be any changes in any of them. And then the next 5 problems will use these formulas. Sometimes forwards, sometimes backwards, but they will use the formulas. So for problem number 12, this is exponential decay because it's decreasing. Decay is the subtraction one. So the initial population of 1 minus your percentage rate. Make sure you are careful with the decimal. 0.013 to the 15th power, because it has been 15 years from 2000 to 2015. Plug that into the calculator exactly the way you see it, and you get 451.98. Now these are fish, so you could probably round up because it's really 451 because this doesn't really form an entire trout, but I'm not going to argue with you about 452 or 451, and I would say that it's really 451 trout. Make sure you do label your answers. So for 13, this is compounded annually. Remember, continuously, we'll use this one because it says compound continuously. So when you see continuously, that's the one with the E. You don't see continuously? Oh, that's trippy. Then you don't use the E. Ah. Okay, I'm not sure what's happening. So we're going to have the initial or the principal as 18,000 times 1 plus 0.03, and we're dealing with 25 years. Remember, this is money. Please label it as such. $37,688. Oh, I was afraid of that. Somehow, that problem is going to float around out there. Sorry about that. My trouts are swimming. All right, so for number 14, this is when they give you kind of the first point and the second point. So it's up to you how you want to do this. We're trying to go backwards with this. So we know that year 0 is 15,000. Year 1 is 15,525. And year 2 is $16,068.38. Up to you how you want to do this. You want to take and put the one that comes second on top of the one before it, or you want to take and put this one on top of that one. It's up to you how whichever you have two choices, and they will result in the same answer. I'm going to use the 15,525 and divide it by the 15,000. This gives you 1.035, but remember, that is the 1 plus r. So you got to take away the 1. So we're dealing with moving the decimal point over now, so this is 3.5%. Because the question asks for a percentage rate, the annual interest rate. So make sure you move the decimal back for your percents. Trying to keep my trout out of my way here. So for number 15, this one's compounded daily. This is your compound interest, not just your regular old interest. So this is the one with the principal, initial amount, 1 plus the rate, 0.035. Since it's daily, we divide by the number of times it's compounded, 365. The power is 365 times the number of years. That can be put into the calculator exactly the way it's written. You don't have to add any parentheses or do anything tricky to it. Now, when you do this, you get $29,780.91. The question wants the interest earned. Be careful with the questions. So now, of course, you have to take that and subtract the 25,000. You can do all this in the calculator, but I'm just showing you how to do this. And so then the answer would be, of course, $4,780.91. That's how much interest was earned, not how much money there would be. Now this one says compounded continuously. So our initial amount, 25,000. E to the 0.05, for that's your rate, times 20. And so this is just wants the amount in the account, not the interest, $67,957.05. Now remember, this is still the part with the calculator. There are 4 of these. 4 solving with the calculator. This says 3 decimal places instead of 4, so follow the directions, I guess. So we're going to put this back together. It's a combination of all the little things that we've done. So condensing, solving, swooping, taking the log of both sides, all this stuff. So if we put this back together, just be careful with this. This is really 4 squared. So we have log base 6 of 4 squared. It's a minus, so we're dividing, over 8 to the 1/3. Now remember, you'll have your calculator, equals log base 6 of x. Now I already know from doing this previously that 8 to the 1/3 is the cube root. So we're looking at the cube root of 8, which is 2. But you can put that in your calculator. The log base 6 is gone from both sides, no swooping, none of that. So this is essentially 16 over 2. That's all this is. And so we get 8. Just a quick check, we don't take the log of anything negative, and we don't. So for 18, let's put this back together. So we have the log of x to the 1/3 is equal to the log of 8. No swooping, the log is gone from both sides, so x to the 1/3 is equal to 8. This is basically asking for the cube root of x. And so to get rid of the cube root, we would basically cube both sides. So 8 to the 3rd, 512. Now, we don't have the log. Remember, the log is like money. If you don't have it, you want it. It's like life. So we don't have log, so we got to put the log in there. So we have to take the log of both sides. So the log of 4 to the x is equal to the log of 100. This allows you to do that one simple thing. X log 4 equals log 100. And then you simply divide by the log of 4. Be careful with your parentheses. You know the calculator is going to open this one, so you got to close it, then hit divide. All right, so just be careful with that so that you can get this to be correct. And so you get x equals 3.322, since we're only going to 3 decimal places. Now here we have e. In order to get rid of e, you take the natural log. So we have the natural log of 60.3 equals the natural log of e to the 0.1t. Well, the natural log and e undo each other. It's gone. And of course, now you know that this comes down out of there. So the natural log is 60.3. Don't lose that. You still have to put that in the calculator. Equals 0.1t. Divide both sides by 0.1. And then at the end is when you put it all in the calculator. So the natural log is 60.3. Close the parentheses. Divided by 0.1. And we get 40.993. For 21, we got to divide both sides by 100. You can do this with a fraction or as a decimal. That's up to you. E to the negative 2x is equal to 0.25. To get rid of the e, you need the natural log. This is gone. Negative 2x equals the natural log of 0.25. Divide both sides by negative 2. So for x, you get 0.693. Still not taking the log of anything negative, so we're good there. For 22, we'll divide both sides by 6. Natural log of x plus 8 is equal to 4. This is a swoop one. You have the natural log. You don't want the natural log. You want the e. Remember, the e is invisible. It's really right there. E to the 4th is equal to x plus 8. You can put this in the calculator, e to the 4th minus 8, to get x. X is 46.598. And number 23. Subtracting is dividing. These are all logs. They're all going to be gone. X squared minus 2x over negative x is equal to, put this back together, x squared. I'm going to actually divide this out. This is x squared over negative x minus 2x over negative x. So when we simplify this a little bit, this is negative x plus 2 equals x squared. I'm going to set this thing equal to 0 and factor it because it's got an x squared and an x. So we get 0 equals x squared plus x minus 2. 2 times 1 is the only way to get 2 and make that a plus 1. So we get x equals negative 2 and x equals 1. Now be careful with this. A lot of times the negative answer doesn't work. Just make sure you check it. So when we go to check the negative 2, I'm going to have the log of negative 2 squared. So that's 4 minus 2 times a minus 2. I'm going to have the log of 0. If you're not sure if you can take the log of 0, put it in your calculator. Does it tell you error? Then when you put the negative 2 in the second part, this is the weird part, is the log of negative 2. So that's actually a positive number. Then when you do the log of the 1, this is the one that gets, so we have the log of that second part of negative 1. When you put that 1 right in here, it doesn't work. So positive 1 doesn't work. Negative 2 doesn't work. So we get no solution. And that's the whole quiz. When the answer is no solution like that, of course, I'm looking at your work. And I'm looking at your work in all of these, so make sure that you do write some stuff out. I know there's a lot of calculator to be used, but that's still should have some work leading up to the calculator, getting it set up so that you have x equals, and then you put it in the calculator last.